Welcome to part numero dos of the Johnny5 part for NYCCNC. You know John Saunders, everybody knows him. If you're watching this, you probably know who it is. So, right now, we have our part in the vise, upside down, and we're going to face it to hopefully 100 dead nuts on the correct height. I get this flip over and face part like right 50% of the time, so we'll see. I just indicated to see if it was flat because flatness is cool, and it's got a little bit of twist in it. I messed with it for a while, but I think the twist is just caused by the aluminum extrusion and not by my fine vise and parallels. So all right, let's do this. First we're gonna grab the work coordinates, G54, so it should do it. All automation like, we're hip with the robots. Oh yeah, that ain't gonna work. Alright, looks like we're gonna have to do this manually. Close. Good work. Oh, come on. Let's see what we won. Very nice, very nice. Feels good, no bumps. Oh no, there's some bumps right there. What the? How could this happen? Huh. Kinda weird that it would... right here. Like, I mean, it's mostly supported. Kind of. It looks bad on camera, but it's like... oh man, that must have been just the spot. Right there. Unless it's a raised burr from the cutter, having like a chip in it. But I'm not that lucky usually, so... alright, let's measure and be disappointed. Alright, as stated, I'm not very lucky with heights, so it's like 371, and it's supposed to be 375, so that's 4,000, so that's like a human hair, so that's kind of bad. But, I'm going to continue forward. We're going to see if I can polish that ledge out. If it's still within 5,000s, because that's the tolerance we got on everything except these bores, then we'll continue on with the part, and it'll be okay, and I'll just have to live with it. Somebody will have to live with it. But inevitably I'll probably screw something up down the line, so we'll have a chance to fix it anyways. So on to what this operation is. So what we're going to do is going to probe this bore here with our, probe, and then we're going to contour, we're going to chamfer all these nice sharp edges. So yeah, you want to make sure you don't have a burr to start where you're going to probe, because if the probe hits this corner of a burr, it's going to update the work coordinates based on that burr, and the burr is not representative of where the rest of things are on your part. So just keep that in mind. Let's do this. Whoops. Okay, let's try this again. Oh, Jesus. Calm down. Alright, third time's gotta be the charm. I don't think this is gonna work. It's gonna be way off. Okay, I gotta probe this in manually. Okay, fourth time's the charm. I had to manually probe the bore in, but now it should do it automatically. Alright, let the chamfering begin. Sweet. Looks like it's gonna work. I have a feeling it didn't cut on the left side. Oh, looks like it did. Alright, let's do this. So we faced the part kind of unsuccessfully. I don't know if I went over that yet. We faced the part yesterday and it's a new day, so now we're looking at doing op 3, I guess that would be. And so for op 3, my plan is to be lazy, and we're going to stick it vertically facing the spindle, like so. And then we need to drill this bore, so we're going to drill, then we're going to interpolate it with an end. Really? Don't you just don't you just love being interrupted by your very loud compressor? So what we were doing was we are going to flip this up, bore this. We need to cut this 90 degree with a normal end mill. Then we're going to chamfer this corner because there's no way to do that obviously when it's sitting up on its face like we had before. So what I'm going to do is first we need to make sure we can actually do this. So I'm going to do inspect from this face down to at least this edge. It's kind of not what I wanted. Hold on. If we do, we should do face. This face to, there's a maximum distance. Okay, this is max distance 2.6. This is what we want, 1.8. So we need to make sure that our end mill that we're going to use, I know the drill is long enough. The end mill we're going to use is not too short because we're going to have to, the end mill I'm using in the holder that I have is definitely going to hit this. The collet nut's going to hit this. So we need to stick the end mill out basically 2 inches, which is pretty crazy for a 3/16 because this hole is 2.213. So only slightly above the size of a 3/16 end mill. So I'm going to measure that, and then we'll go over the tool path stuff in a second. Okay, I'm going to take my end mill, and we're going to measure 2 inches out of this collet. Stick that bad boy in there. Take your calipers. I'm going to shut the fan off. Very loud in here. So currently we have 6.2, which is a good size stick out for a 3/16 end mill. But what we need is 2 inches. That's all she's gonna get. Oops, that was tiny. We're gonna take it and basically clean out this because it's pretty dirty. Then I'm gonna wipe out the actual bore where the collet sits, which is usually pretty dirty. So I'm gonna take this guy, put that back in there like so. Clean the chips off the end mill. And we gotta measure 2 inches to stick out. I'm not sure why I got the 1.8 number, but I'm looking at this. Here's our end mill. So 3/16 end mill. Here's our part. We gotta cut from this shoulder down to this slot. And as you can see, there's a pretty decent amount of shaft we can grab onto, so I'm not entirely sure. Here's the other one. That one's going to be pretty easy. So I'm not entirely sure where that number, I obviously read the measurement wrong in Fusion, so I'm just going to stick it out by eyeball, and then I'm going to add the distance in Fusion, and we'll run the simulation and we'll see if it hits. That's a good way to check it, but you got to make sure your measurements on the actual tool are accurate, you know, within a couple, you know, 10,000ths. So this is exactly what I'm talking about. Collet nut. So that reaches fine. It's close, but not there. So that should work. That should just barely work. So now what I'm going to do, I'm going to tighten that up. Quite the stick out for a 3/16, but we're going to go nice and slow, and it's aluminum, so we'll be okay. The machine needs to do all the work anyways. Get her nice and tight, and then we'll check it. So from the face of the collet, we're looking at 1.354. So I like to add like 0.005 in just as a safety factor. That way Fusion, that gives us that little bit of margin of error, I guess, that may save the collet nut, as you can see. I'm pretty used to slamming collet nuts into material, so let's try not to do that. So we'll go add this. We'll change up the tool in Fusion and make sure that it's actually properly simulating. And then what we'll do is we'll put in the Haas, and then we'll actually do the tool offset and everything. Alright, let's see. Back in the software, we're going to set this job up. And then, like I said, I'll show you guys how to do that tool update simulation thing. So we're going to do a new setup for our op4, basically. I'm going to call this program 4. There's going to be work coordinate 2. Excuse me. Model is going to be this body. Stock is going to be this guy. We're going to change the thing to selected point. If I could find. Yeah, see, what I want to do is I want to grab this corner as the stock 0. So what we're going to have to do, we'll say okay that setup. We'll go back into design, and what I'm going to do, make sure we're selected on our part. I'm going to create a sketch on this top face. Why is it not straight? That doesn't really matter, I guess. And we're going to add a point to the midpoint of that corner. Finish sketch. Go back into manufacture. Now what you can do, what is with my thing? For some reason Fusion's been buggy for like the last 6 months, and sometimes it just breaks the orbit, which is super frustrating. Okay, we got our point. We're going to go back to our setup in manufacture, and then we're going to select, we'll change this to selected point, then we can click on that, and we're good. Our XY is good because I have the whole table orientated the correct way. So let's see, the first thing we're going to want to do is, so what I'm going to do is just do a 2D contour. We're going to select our 3/16 ML, which I need to change. So we're going to edit, and this is when you're going to put that new measurement in. 1/3. Oh god. That's the distance. That's quite the distance. I'm going to say okay. Say okay to that. Then just, I'll do the feeds in the speed. It feeds in a second. Click on that corner, and we'll say okay. Make sure that's going to work. That's good. I kind of want to extend the leads just so it's not touching the part. So we'll do linear lead-in distance. We'll say 0.1. And change the angle that it comes at it. Let's say 45. Cool. So that's going to come down. Shouldn't be touching the part. And yeah. And what we also want to do is do stock to leave. And we're going to say... We're going to say 0.1 on that, and we'll say 0.5 on that, because what's going to happen is, since we just changed the distance and I cleaned the collet nut out, you might have changed the run out on the actual end mill, and we don't want to have a blend issue, because this part's already finished. Actually, we're just trying to clean up that inner radius, and I would hate for the tooling marks to show up. Sweet. Alright, that's done. Then what we're going to do, let's do drill. We'll select we'll do bore, and then I'll select this, and I want to go just 5 thou below. Cool. And then, so we're going to give that a shot. I mean, we're going pretty slow, honestly. We're just going to be 20 inches per minute. So then, last thing we're going to do is, yep, 2D chamfer, edit this. Okay, yeah, that's better. So check this one last time. Just going to do that. We're going to do this. And then we're going to come in here and fix that corner. Okay, so... steps to actually get it machined. We need to make sure we recheck the tool height for this tool, which is tool 3, and then what we're going to do is going to probe this and make sure this is our G55, which is work offset 2. And we'll just take it slow. We'll go from there. Okay, let's set this tool up. Tool 3, grab your handy dandy tape measure. 4 entire inches. Not used to seeing that much length. I'm going to take this, we're going to stick it in the right vise, and then I'm going to actually indicate the top to make sure it's 0, 0 all the way flat, and then we'll probe it in and do G55. And take your mag base. I use one of these Noga bases, super worth the money. We have our indicator. So I'm just going to check the hard jaw on the back just to make sure the vise is square, because if we cut this contour on that shoulder and it's not square, well, you're gonna have pretty bad mill marks on it. So this is a 10th indicator, so this is pretty serious business. So that's good, within the 10th basically. I don't know if the camera picked it up, but the vise hasn't moved, so that's a good sign. Make sure you remember what side the part is actually going to be, so we have the big part on the bottom, and then with the shoulder facing the right side. So just give it a little light snug. Then we're going to indicate the top end. And then, so we got that on there. I don't know if you guys are going to be able to really tell, but then we'll just sweep across it. Okay, so this is a really short distance, so it's not necessarily the best way to do this because, well, it's such a short distance, but it's a good sign anyways. So here we are, there's 50 on the scale, or 5/10 on the scale, or 5/1000. And it doesn't move, so what I'm going to do is I'm going to tighten the vise down. It moves a little bit, we'll check it again. So well under 1,000, pretty much closer to 2/10. So that's a pretty good indication that things should be okay. Cool, so remember we're going to indicate up on this peak basically. There he goes. This guy right here, right in the middle. Okay, then we're going to handle jog over and down to do our X, which is going to be, I think, in the positive direction. So again, single surface, do X, and we'll do 0.2. Is get our Y, which is the middle of that thing. So how I'm going to do that is you go into the edits, and then you can do web y-axis, and then our y distance is only 0.5, and we're going to say minus 0.5 in the z distance. Alright, let's let her rip. I'm going to bring this in, go really slow, make sure your positions are good, and looks like we're not going to crash it, so that's a good sign. That's where we are right now. So I'm going to go ahead and turn coolant on. Cool. That's going to do our bore. So, I can't really tell if the chamfer on the top's good, right there, but there's a slight lip on there. There is, I need to go in radially that way. There's plenty of meat to cut, so that's why we left 5 out. The floor, I think, is literally just a physical defect, and it's really hard to, like, I don't think you can feel it. So, let's see, another thing is, we need to check this size. It needs to be 213, so we'll just pin gauge it or roll gauge it or whatever. But there's no chamfer on this hole, which kind of sucks because I kind of like the look of the chamfer. So I'm thinking my 1/2 inch spot drill, I'm wondering if that'll fit. Now in the simulation, it literally shows the spot drill being hugging this wall, but it doesn't show it actually contacting the wall, which is kind of weird. So we're going to switch to the spot drill, and I'm going to measure it, and if it's actually less than 0.5, we might actually try to drill that for a chamfer, because I can't use the chamfer that I have because the stick out will be like super far. So yeah, let's switch to the center or the spot, and I'm gonna see if it'll actually work. Let's try again. Oh boy. It didn't hit it. Yes. Amazing. That's fantastic. I think because in Fusion it shows it as 0.5, but it's actually like 0.47. Look at her. I mean, it's probably a little overkill compared to these ones. But this also cleaned up pretty good. I know it looks pretty bad on camera as far as like cleanup goes, but I honestly can't feel it. My thing is though, I'm pretty sure the corner of that end mill is chipped, like all the corners. So there's probably a really tiny radius in there. I think you can kind of see it. It's like the little white line down at the bottom is a little radius. That, and then now it's got a little burr on there. So we might have to do another contour pass around when it's sitting. But you know, I don't know if the 90-degree chamfer can actually cut that corner. So I don't even know if it's worth it. I think maybe we'll just have to hand sand it with a file or something. So yeah. That's good. Alright, so what we're going to do is we're going to keep boring this out until we get to 213 and the pin gauge slides through. And yeah, then we'll do the other side. Oh yeah, not even 0.2, so we got a ways to go. So let me go set up a contour toolpath and then we'll cut that again. Well, that has done absolutely nothing for us. Let's run that thing one more time. Unfortunately, 215 fits now, so 216 probably fits. So 215, that's the size of the hole, I believe, and the reason it's not going all the way through is because we have that backside burr. So, yeah. Other than that, I think it can come out and we can do the other side. Alright, I'm going to call that pretty successful. So a 215 pin fits, but a 213 pin goes all the way through. So it's a 215 hole, but there's this really hard to get to burr on the backside here. It's impossible for me to clean it up without some sort of backside tool. Shell. 215 is good enough for this. That's within 5 for that. And then, yeah, the holes all cleaned up on the top, so that's good. So we're going to go ahead and do this side, and then we'll figure out how to do this one too. So let's do it. Same thing, I'm going to put it in here, and then I'm going to make sure, I'm just going to indicate off the top and make sure it's flat, and then we'll go ahead and go over the tool path for it. Alright, so it's within 2/10 of flat, so I'm happy with that. Alright, let's talk about the tool path now. Okay, this is going to be op 4. This is the other side of this part, the other bore on the top, if you will. I'm trying to rename this thing, but Fusion doesn't like me. Part Op 4. Cool. So we're going to go into manufacturer. We're going to copy setup 5, and we're just going to paste. That's going to become Op 5. All right, simulate it just to make sure we're not going to hit anything. I'm seeing a bunch of red already. That's always a good sign. Okay, yep, I'm seeing what the issue is, so we're going to back up. We're going to, let's see. Oh yeah, that's definitely going to hit. So it looks like we're going to have to stick the tool out even farther. Alright, ready to start this operation. I stuck the tool out a little bit farther to get the offsets going, because nobody wants to see me do that all over again. So let's do it. Oh yeah, that sounds beautiful. Oh yeah. The sound of my people. Wow, that was super trippy. It looked like the part was doing this. I mean, maybe it was, but it's still in there solid. That gave me like a super big headache, because yeah, that was super weird. Oh yeah, let's see this disastrous thing. Fusion now says it'll hit, so I'm not too sure. Nope. You don't know Fusion. Okay, so let's see what we got. Definitely tell that the borer is chattering like mad, because you can see in the... Kind of hard to pick it up on camera, but there's like chatter marks in the bore. So yeah, maybe I need to buy a reamer for this. There's 215. So it looks like 215. So that's good, that's too foul. I need to figure out how to clean up that inside in that slot. I mean, the chamfer on the top edge does not look that good. I'm gonna rerun it. Alright, this doesn't look terrible. Chamfer looks good up here. I mean, you can see where the tool came in and did that corner, but the worst part about this is the bore, and it's literally because I had to stick the tool out that far, so the chatter marks are there, but it is 215, which is 2 thou over what we're supposed to be, and the 216 pin doesn't fit, so I know we're within tolerance. I'm not entirely sure if the chatter thing will matter much. I'm pretty sure it's just going to be my personal pride opinion, but I'm going to go eat something. I'm starving, and then what we're going to do is we're going to go ahead and do this angled bore, and that one should be relatively easy to do as compared to doing these because of the distance of the actual bore. So yeah, I'll be back. Okay guys, here's the final operation for this thing, minus these holes that I gotta do later, but I'm waiting on a reamer. Basically, we just need to bore out this counter bore and then this actual bore, and I'm gonna do that with an 1/8 end mill because I don't have a reamer. Fine size, typical story. This is kind of a unique thing for this in a traditional vise kind of setup because obviously this has got to be perpendicular to the spindle, and there's no real good place to get a normal XYZ, so what I decided to do was Z is going to be this perpendicular face. Y is obviously just the backside of the vise, so that's really quite easy. And X is the most difficult part, so what we're going to do is we're going to take one of those pin gauges, stick it in there, and then we're going to get our X off the center point of that pin gauge. So that seems pretty straightforward, I think. So yeah, let's head over the machine and get this ball rolling. Here's that pin I was telling you guys about. It's a 249 thou pin, so if we can't probe it by doing the web X, we'll just have to probe one side and then subtract half the distance. Blah, 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 blah. Okay, well, in video it's obviously not going to be as long, but here's what we got. Zerma's 10th indicator. I will jog it down so you guys can kind of see. So there's 5. So within 2/10, so that's good enough for me. Especially now that it's tight, so if I wanted to move it, it'd be kind of a pain. So now what we're going to do is we're going to indicate on this pin for X, and then everything else is pretty self-explanatory. But that's the only weird thing about this setup. Okay, now what we're going to do is send it in there. Nice and slow like. And what we're going to do is make sure it looks like it's in the right place. Whoops. I think what happened was, well, I'm not entirely sure what happened because I could have sworn that, well, this part's ruined, but I'm going to do this. I've seen the error of my ways. So what basically happened was, oh, you guys don't fit under there. So basically what happened was the work offset was set to 1, which is G54, and I was using G55. So, yep, that just goes to show you that you should probably pay attention when you're posting stuff out. And yeah. Oh well, there's some couple issues with this one anyways, so that gives me an opportunity to redo them on the next one, which will be now the 4th time. But I think this is going to conclude this video. Obviously, you guys probably don't want to spend another 30 minutes watching me make a whole nother one. So, yeah. Thanks for watching. If you like this stuff, please subscribe. I'm trying to get 100 subscribers by the end of the year, and I'm pretty sure that's a completely doable goal because I think I'm at 48. So, yeah. Have a good one. Okay, well, I couldn't really leave on such a low note, so I decided that I'm going to toss in another tool, and we're going to at least see if this toolpath was going to work, because why the hell not? Well, that's a hole. Okay, well, it works. Now, thanks for watching.